Hello everyone, welcome to the Electron Flow Academy. So today's our topic is based on the numerical problem, which is based on three-phase AC delta connected load. Okay, so I am clearing that in the delta connected load, in this condition, the phase voltage is equal to the line voltage. Okay, so this is the condition in the delta connected load, and the phase current is equal to the line current divided by root 3. Okay, so this is the condition which is based on that delta connected loop. Okay, so the numerical problem is as follows, that three coil of the equal impedance of 4 plus j3 ohms are connected in the delta across 400 volt 50 hertz supply. So find the current in the each coil. Here we need to calculate the each coil current, line current, active, reactive, and apparent power. Okay, so let's start the solution of this question. So firstly, the impedance per phase is ZP equal to, given us 4 plus J3. If I convert this rectangular into polar, then I will get 5 at an angle of 36.869 degree. Okay, and as I said that for delta connected load, phase voltage is equal to the line voltage, which is given us is 400 volt. Okay, so this is given us here 400 volt. Okay, so therefore the current per phase in each coil is, so current per phase or in each coil is given by IP equal to phase voltage divided by phase impedance. Okay, so we have the value of the phase voltage and also we have the value of the phase impedance here. So here we can calculate the phase current. So this equal to 400 at an angle of 0 degree divided by 5 at an angle of 36.869 degree. So value is here is equal to 80 at an angle of minus 36.869 degree. Okay, so here if I talk about the phase current, if I talk about the phase current, so I am assuming that there are three phases. First one is the IA. So I have calculated the value of the IA, which is equal to 80 at an angle of 36.869 degree. Okay, next another phase current, which is equal to IB, 80 at an angle of, this one is 120 degree apart from A phase. So this will be minus, sorry, minus 36 plus 120. So it will equal to minus 156. Okay, 0.869 degree. same as it is the phase current C, which is again 120 degree apart from the IB. So that value is 88 angle of 156 plus 120. So which is equal to minus of 276.869 degree. Okay. So this is we have calculated how this is how we have calculated the current in each coil. Okay. So next is that since we have taken per phase voltage as a reference here, we have taken per phase voltage as reference. Okay. So the individual per phase current will phase current will lag the corresponding phase voltage by an angle of 36.869 degree. Okay. So basically the line current in the delta is now the line current in delta is equal to, we know that line current is equal to root 3 times of the phase current. So this is equal to root 3 into IP. So we have calculated the magnitude of the phase current, which is 80. Okay, it is 80. This you can see here is equal to 80. Root 3 into 80. Change the color 80. Okay, so the line current is equal to 138.6 ampere. Okay, so this is how we have calculated the line current. Okay, so now we know that in the delta connected system, line current lags the respective phase current by 30 degree. Okay, so the power factor of the load is equal to cos of 36.869 degree. Okay, so power factor is equal to now this is the lagging. Okay, so cos of phi equal to 0.8. Okay, so here we can calculate the value of the sine phi, which is equal to sine 36.869 degree. Okay, so the value of the sine phi is equal to 0.6. Okay, so those values will help us to calculate the active, reactive, and apparent power. That is the reason I have calculated here cos phi and the sine phi. Okay, next thing is that firstly we will have calculate the active power. The formula for the active power is P is equal to root 3 VLIL cos phi. Okay, So root 3 into, we know that the value of the line voltage is 400. Value for the line current is 138.6 here and multiplied by 0.8. Okay. So the active power is equal to 76819.9 watts, or we can rewrite this in kilowatt like 76.81 or 82 kilowatt. Okay, so this is our active power. Next, we need to calculate the reactive power. Okay, so the formula for the reactive power is here. Reactive power is denoted by Q. The formula for the reactive power is root 3 VL IL sine phi. Okay, so Q is equal to root 3 into again 400 into 138.6 into 0.8. So the reactive power I get here is 5714.9 VAR. Okay, this is the unit for the reactive power. Or I can rewrite this 57.615 kilo VAR. Okay, so this is how I have calculated the reactive power. Okay, last one is the apparent power. So here, apparent power, which is denoted by as the formula for the apparent power is, in the case of the three phase, is root 3 VLIL. Okay, so S is equal to again root 3 into 400 into 138.6. So the apparent power I get here is 96024.8 VA. Okay, VA is the unit for the apparent power. Or I can rewrite this 96.025 kVA. Okay, so lastly we have calculated the active power, reactive power and the apparent power for the given question. Okay, so this is how we have calculated the parameter in the case of the delta connected load. Okay, so thank you very much. Please like and subscribe our channel.